3.2D. Okay, now we're going to put all that we've learned and apply it to a new problem we haven't seen before. Example, find any relative extrema and inflection point and graph f of x equals x to the fourth minus 2x squared. Okay, what we need to find out are our critical points. So to find our critical points, we need to find our critical values. Critical values, and then we're going to find our critical points. And we can graph our critical points. Okay, first thing we need to do is find the derivative of f. The derivative of x to the fourth is 4x cubed. Derivative of negative 2x squared is negative 4x. Okay, then we set it to 0 to find our critical values. 4x cubed minus 4x. We can go ahead and pull out a 4x, and we get x squared minus 1, and that'll equal 4x times x plus 1 times x minus 1. All right, so now we find all x for which f prime of x will equal 0. So we say for x equals 0, so x would equal 0 here, x would equal negative 1 here, and x would equal 1 here. So these are our critical values. Now we want to find our critical points. So we put in our values. F of 0. If we put in a 0 into here, we just get 0. So our critical point is going to be 0, 0. Next one, we put in a negative 1. If we put in a negative 1 into our original equation, we get negative 1, which just turns to a 1 here, minus 2, and that's just going to equal negative 1. So we have a critical point at negative 1, negative 1. Okay, now we're going to put in our third critical value, which is 1. So f of 1, we put a 1 in here, we get 1 minus 2 again, and that's negative 1. So our critical point is 1, negative 1. So we're going to utilize these to find out if they are relative max or mins. So we're going to draw our little number line. We know we have critical values at negative 1, 0, and 1. So now we're going to look at the intervals. Here it's from negative 1 to negative infinity. Here it's going to be from 0 to negative 1. And here it's going to be from 0 to 1. And here it's going to be from 1 to positive infinity. So now we test points. Okay, so for this one we'll choose negative 2. F prime of negative 2 is going to be 4 times, because this is f prime of x, negative 2 cubed minus 4 times negative 2. Okay, now that ends up being negative 32 plus 8. And we don't have to keep going on. We just need to know if this is positive or negative, the end result. And it's negative. That's all that we're looking for. So we put that little minus sign there. Okay, next one. What are we going to test between 0 and negative 1? We can test 0.5, negative 0.5. So f prime of negative 0.5. Now when we put that in there, it ends up being a positive number. Okay, now we're going to test 0.5 here too, f prime of 0.5. And when we put 0.5 into our original derivative, we get a negative value at the end. And now when we put in a 2, f prime of 2, the end result's going to be a positive value. Okay, so now that we know that this is going from negative to positive, is this going to be a max or a min? Remember our first derivative theorem? It was the test for relative extrema. So here we have f prime of x is less than 0. Here we have f prime of x is greater than 0. So f prime of x equals 0 here. So this is a max or a min. What do you think? If it goes this way and then this way, this is going to be a min. Okay. Now for this one, we have a positive to a negative. So we have a positive to a negative. This is going to be a max. And on this one, we have a negative to a positive. So this is going to be a min. Okay, so now we can state that in our answer. We're going to say our relative max happens at point 0, 0. Our relative mins happened at points -1, -1, and also at 1, -1. Okay, let's go further. Now we want to know where the inflection points are. So for inflection points, is there going to be more than one? We're also going to be looking at concaving up and concaving down. So we're going to take the second derivative. Second derivative is 12x squared minus 4. Now we set it to 0. 0 equals 12x squared minus 4. We're going to factor out a 4, and we get 3x squared minus 1. We have to solve for this where the double derivative equals 0, second derivative. Okay, so we have 3x squared minus 1 equals 0. 3x squared equals 1. X squared equals 1/3. X equals the plus or minus square root of 1 over 3. Okay, that can be rewritten. Square root of 1 is 1. Or we can rationalize the denominator. We'll just leave it like this. Okay, so now we need to find some points. We're going to put that into the original equation. F of 1 over square root of 3. We'll put in the positive 1 first. And when we do that, we get 1 over square root of 3 to the 4th power minus 2, 1 over square root of 3 to the 2nd power. When you take this to the 4th power, we're going to get 1/9. Minus 2, this to the 2nd power is just 1/3. Okay, so now we have, when you combine this, we're going to be getting -5/9 as our answer. So what did we find? We found a point 1 square root of 3, -5/9. Okay, now what is that point going to be? Is that going to be an inflection point? Is that going to be a relative extrema? Well, we already found our relative max and min, so this is going to be an inflection point. Let's see if we can find the other one, because we noticed we had plus or minus. Plus or minus, we just did the plus. So let's do the minus one now. Okay. F of -1 over square roots of 3. All right. That equals -1 over square roots of 3 to the 4th power minus 2, -1 over square roots of 3 to the 2nd power. Now when we do all this, you know what's going to happen because this is an even exponent, right? We're going to get the same thing, minus 2, and this becomes times 1/3. And when we're all done, we're also going to get -5/9. So now we have -1 square roots of 3, -5/9. Those are our inflection points. Inflection points. All right. Okay, now let's draw our little line, our graph, to test for concavity. Okay, so this is at negative 1 over square root of 3. This is at 1 over square root of 3. So we are going to be testing f double prime x to look to see if it concaves up or concaves down, because we know these are our inflection points. Okay, so we're going to be looking at from negative 1 over square root of 3 to negative infinity. That's our interval we're going to be testing there. Then we're going to be testing our interval from negative 1 over square root of 3 to 1 over square root of 3. Then we'll be testing over here our interval from 1 over square root of 3 to infinity. Okay, so let's pick a number that's out here. Let's choose negative 1. F double prime of negative 1. Okay, f double prime of negative 1 is going to be 12 minus 4, which equals 8, which is greater than 0. So if it's greater than 0, is it going to concave up or down? You're right, it's going to concave up. Okay, so we're testing the second derivative for concavity. Let's choose another point that's in here. Let's choose 0, f double prime of 0. And that equals negative 4, which is less than 0. So since it's less than 0, is it going to concave up or down? You're right, it's going to concave down. All right, now we're going to test here. How about f of 1? F double prime 1. And that equals 8, and that's greater than 0. So that's going to concave up. So we're going to finish this problem now and do our best to graph this. We know we have concave up, concave down, concave up. So we have a lot of information now to make this graph. Okay, we have critical points at negative 1 and 1. We know that we're concaving up, concaving down, concaving up. We have to look at all of our points now that we have. Okay, so we have our relative max at 0, 0. That's a relative max. We know we have a relative min at negative 1, negative 1. There's negative 1. We know we have another relative min at 1, negative 1. All right, let's keep going. We know we have concave up, concave down. If this is our max and this concaves up, it's going to look something like this. Oops. This was concave up. There we go. This concaves down, and this concaves up. Now, where does it cross the x-axis? We'd have to test when y equals 0. So we would have to solve 0 equals x to the 4th minus 2x squared. 0 equals x squared times x squared minus 2. So x would equal 0 in this case, and x would equal plus or minus square root of 2 in that case, which is approximately 1.4. So that's where we would put where it crosses 0. We know it crosses here, the y-axis, at 0. There's our first one. And our second one is plus square root of 2, which is approximately 1.4 here. That's what this equals. So 1.4 is about here. So it's going to look something like this. And negative 1.4 is about here. There you go. And we're all done.